So the one is going to reference this graph. So it says on part A, determine f of negative 1. So this negative 1 is an x value, right? And so I'm going to go over here on my x-axis to negative 1, and I'm going to find where I can see the graph. I see if I go up 1, I see a hole there, but if I go down 1, I can see the y value, and so I can see that f of negative 1 is negative 1. And to determine f of 1, I'm going to go here to 1 on the x-axis, that's here. And I'll go up to my graph, and I can see that the y-coordinate corresponding with that is 3. The next thing I want to do is determine all the x-intercepts. So that's all the places that my graph intersects the x-axis. And I can see that there's no blue that touches the x-axis. So there are none of those. And then the last one says I want to find all the x for which f of x equals 1. And so if I go here to 1 on my y-axis, I want to see all the places where f of x equals 1. And it looks like I just have 1. It would be there, except that that is a hole. So it looks like the only x for which f of x equals 1 is 2. Okay, so for the next one, let me erase the graph here so I can see. Determine the y-intercept. So the y-intercept is going to be where it crosses the y-axis. I can see that happens right here at when y equals 2. So I can say y equals 2. Or if you want to write it as a point, you can write 0, 2. Okay, the next one asks for the domain of f. That would be all the possible x values for which it's defined. And so if I go along here to all these different x values, I can see that I'm going to hit the graph at each of these x values. And so this is actually defined for all x values. If you look here at negative 1 is the only one that seems interesting, but the graph is defined at negative 1, and it's defined everywhere else too. So the domain is all real numbers, or you can write negative infinity to infinity. So determine the range of f. So the range is going to be all of the y values that the graph attains. So if I look at y values, I can see that the graph hits all the y values that are less than negative 1, and it also hits negative 1. But anything between negative 1 and 1, there's no graph for any of those y values. And then if I go here from 1 to infinity, because of this arrow here, I can see that it's going to hit all the y values from 1 to infinity. And it actually does hit at 1 because the graph is defined at 1 right here. When y equals 1, we do hit the graph there. And so it looks like everything from negative infinity to negative 1 union, everything from 1 to infinity. Oh, and I need to put, I should put brackets there instead of parentheses. So let's see if I can, oops. Let me see my eraser. See if I can get rid of these guys, because I really need brackets there, because I'm including the 1 and negative 1 there. Okay, let's see. Oh, now it's thick. Okay. All right. And so the last one says, I want to determine, let me erase all this. Okay, so on the very last one, it says, find all x for which f of x equals negative 2. So that negative 2 is a y value there. And so if I go down here to y equals negative 2 and I go across, looks like it only hits negative 2 for one x value, and that is x equal negative 2. So x equal negative 2. is the only x value where the function achieves the y value, -2. All right, so the next one, I want to find a slope of the following. So the line defined by x equals 5, and so if I think about that line, if I go over here to x equal 5, that would be this line here. And the slope of that, we would say, is undefined, or we could say infinite slope. So we'll say undefined. And a line defined by y equals -2. So what's that mean? That means the y value is -2. So all the points with that y value would be this line. And so that's a horizontal line. And so the slope over that, the rise over run, since the rise is 0, we have 0 over 1, so the slope of that is 0. Write the equation in slope-intercept form that passes through the point 47 and has slope 1/2. Okay, so let me erase and make some room over here. All right, so I know the slope is going to be 1/2. And so if I think about y equals m, well, we could do it with y equals mx plus b, but let's do it with the slope, point slope form. You know, y minus y1 equals m times x minus x1. And the reason I think point slope form is nice here is because I have a point and a slope. And so my point here, this x1, y1, I can plug those values in here to my point slope form, and I can also plug that m in. So I'm going to have y minus -7 is equal to -1/2 times x minus 4. And then I can spend some time simplifying that. And so I get y plus 7 equals -1/2 x. And then when I multiply that -1/2 by the -4, I get positive 2. And then I can subtract the 7 over, and I get y equals -1/2 x. Let's see. 2 minus 7 is -5. So that's my answer. Okay, the next one says write the equation of the line in slope-intercept form. Oh, yeah, that passes through the points -2, 5, and 6, -1. And so here what I can do is, first of all, I can figure out what the slope is. So the slope, m, equals, well, it's going to be the change in y over the change in x. And so if I plug in those points, I'll have here, there's my x1, y1, and here's my x2, y2. And I can plug in all those points and see how what the rise over run is. So if I do -1 minus 5 over 6 minus -2, let's simplify that. So -1 minus 5, that's -6 on top. And on bottom, 6 minus -2, that's 6 plus 2, that's 8. And so I can simplify that and I get -3/4. Now that's just my slope. I haven't found the equation yet. But I'm going to go over here and I'm going to use the point slope form again. And then I can simplify. Well, actually, let me show you a different way to do it. So let's do, this time, let's do slope-intercept. We could do point slope form again, but let's do slope-intercept form this time. So here I have this y equals mx plus b. And I know what the m is. And I can plug in a point to solve for b. This is just another method for finding the equation of a line. And so I'm going to pick the point -2, 5, and I'm going to plug that in for x and y. And so I'll get 5 equals -3/4 times -2 plus b. And then I can solve that for b. So when I multiply those two together, I'm going to get, let's see, that gives me 6/4, which I can simplify to 3/2. So I have 5 equals 3/2 b plus b. plus b. And I can subtract that 3 halves over. And I get, let's see, how many halves are there in 5? There are 10 halves minus 3 halves is b, so that means that b is 7 halves. Now, I'm not quite done yet because I just found the b. I know the m now, and now I know the b, so I can put it all together. So the equation of my line is y equals negative 3/4 x plus 7 halves. And that's the answer then to part number 13. Okay, and on number 14, it says the population of Dallas went from that in 2000 to that in 2005. I want to find the average rate of change over a 5-year period. So when I want to find the average rate of change here, I'm going to do change in population over change in years. Okay, and we always do the change in our dependent variable over the change in the independent variable. If you're not sure which is which here, just think about it. Does the population of Dallas determine the date, or does the year determine the population of Dallas? So clearly the population is going to be dependent on the year, not the other way around, because that wouldn't make any sense at all. So let's do the change in population over change in years. So we'll do 1,246,000 minus 1,191,000. We want to do all of that divided by 5. Oh, sorry. Let's say 2005 minus 2000, which is going to be 5. All right, so if I subtract those two, on top I get 55,000 over 5. And if I divide that by 5, I get 11,000. Let's think about the units of that. What does that mean? Well, what were the units of the top? The units at the top were people, and the units at the bottom were years. So the units of this 11,000 are people per year. So what does that mean? That means the population is growing because that change in people per year is positive. And it's growing by approximately 11,000 people each year in that 5-year period. Okay. The next one says determine the average rate of change of that function on the given intervals. And so the first thing you want to think about is, what does this mean here, this notation? So these are intervals of x values. So this is like x. These are x values. Both of these are x. So we could say this is like x1 and x2. So what I need to do is I need to find the y values that correspond to those x values. And the way I would find those y values is I would plug them into my function. And that is how I would write down the average rate of change. So let me erase over here. And we can do that. And so what we want to do is we want to do the change in the y values, so f of x2 minus f of x1 over x2 minus x1. That's what we want to do here. So let's find those values. So what is f of x1? F of 1 is equal to 2 times 1 squared minus 3. And so 1 squared is 1, 1 times 2 is 2, and 2 minus 3 is negative 1. And then what is f of 2? So it's going to be 2 times 2 squared minus 3. Okay, 2 squared is 4, multiply that by 2, I get 8. 8 minus 3 is 5. So let's go ahead and plug that in. So I get 5 minus negative 1 over 2 minus 1. And so when I do 5 minus negative 1, I get positive 6 over 1. So the answer there is 6. For that rate of change. Okay, and let's do the other one. Okay, and so again, this is my x1 and this is my x2. So that's an interval of x values. So I can plug both of those into my function here and find the y values that go with those. So what's the y value that goes with negative 3? So f of negative 3 is going to be 2 times negative 3 squared minus 3. Okay, so negative 3 squared is 9. 9 times 2 is 18. 18 minus 3 is 15. Okay, and then if I plug in negative 2 into that, I'm going to get 2 times negative 2 squared minus 3. Let's see. Negative 2 squared is 4 times 2 is 8. 8 minus 3 is 5. Okay, so my y values are going to be 15 minus 5 over, and then my x values are negative 2 minus negative 3. Okay, on the top I've got 10, and on the bottom I have negative 2 plus 3, which is 1. And the answer there is 10, is my average rate of change.